morning students, welcome to physics class. In the previous classes we have learned about acceleration. So what is acceleration? It is the rate of change in velocity with respect to the direction. And next, what is uniform circular motion? When can we say an object is in uniform circular motion? When the object is moving with constant speed and in circular path we can say that the object is in circular motion. So is uniform circular motion an accelerated motion? Yes, it is an accelerated motion. Why is it an accelerated motion? Because when the object is moving in a circular path, so whenever it moves in a circular path, the direction changes. So when the direction changes, the velocity changes. So whenever there is a change in velocity, there is an acceleration. So we can say that the uniform circular motion is an accelerated motion. And where is this accelerated motion acting? So either it is acting outwards of the circular path or it is acting inwards. So this acceleration is acting inwards. Okay. So how do we call this inward acceleration? How do we call the acceleration that is acting inwards? The acceleration is called centripetal acceleration. So whenever there is an acceleration that is pointing inwards, there will be a force that is acting along with the acceleration, and that force is called as the centripetal force. So centripetal means center seeking. The acceleration is acting towards the center. So therefore, the force along with the acceleration is also acting towards the center, and so the force is called as a centripetal force. What is the centripetal force? The force acting on a moving body in a circular path and directed towards the center is called as a centripetal force. So in a uniform circular motion, the force that is acting towards the center is called as a centripetal force. Now let us derive an equation for centripetal force. Now consider an object moving with mass m, radius r, with velocity v in a circular path. Its centripetal acceleration is given by the formula A is equal to v square by r. And we know the standard formula for the force F is equal to m into A, that is mass into acceleration. So for substituting A is equal to v square by r, this is equal to m into v square by r. So now the formula for the centripetal force is mv square by r meter per second. So what is the formula for centripetal force? So F is equal to mv square by r. Now look at these pictures. These are the examples of centripetal force. The first one is the spinning of a ball on a string. The centripetal force is provided by the force of tension on the rope that pulls the object towards the center. The next is the moving of a car. The centripetal force is provided by the frictional force between the ground and the wheel. The next is the riding in a roller coaster. The force is provided by the normal force as the seat pushes us towards the center. The last example is this planet revolving around the sun, and here the centripetal force is provided by the gravity. Let us learn centrifugal force. The force acting on a body away from the center of a circular path is called as the centrifugal force. The centrifugal force is a pulling force acting away from the center, which is opposite to that of the centripetal force. So whenever there is a centripetal force acting on an object in a circular path, there will be a centrifugal force which is acting opposite to the centripetal force. The examples for centrifugal forces: merry-go-round. So when a person is having a ride in a merry-go-round, the person will be pulled outwards due to the centrifugal force. Next, the dryer in a washing machine. When we observe after the dryer in a washing machine, the cloths will be outer rim of the washing machine than towards the center. So look at the picture. A ball is rotated. So when the ball is rotated, see there a centripetal force is acting inwards, and there is a centrifugal force which is acting outwards, pulling the ball outwards. So there will be a pulling force, which is the centrifugal force. So opposite to that of the centrifugal force is the centripetal force, which makes the object to move in a circular path. When we go for a ride in a merry-go-round, we will experience an outward pull as merry-go-round rotates about the vertical axis. This is due to the centrifugal force. Look at the picture. The people, those who are having a ride in a merry-go-round, they are directed outwards because of the centrifugal force. Look at the picture. It is the spin dryer of a washing machine. The centrifugal force acts along the radius outwards and hence used to throw the water molecules on the clothes radially outwards while it is in the dryer mode. Look at the picture. So 1 denotes the rotating metal drum. The 2 and 3 denotes the wet cloth. 4 the water droplets that are radially outwards, and the 5th one is the letting out of the droplets from the dryer drum. Let us recall, what is centripetal force? The force acting on a body moving in a circular path directed towards the center is called as the centripetal force, and the formula is F is equal to mv square. The magnetic force, gravitational force, frictional force, everything comes under the centripetal force. Next, what is centrifugal force? The force acting on a body away from the center of a circular path is called as the centrifugal force, which is the force which is opposite to that of the centripetal force. And the examples for a centrifugal force is merry-go-round and dryer in a washing machine.